I'm pretty sure the video made you a bit sad as you went mentally to the department, but COVID brought us back to our senses and it made us more longing to visit the campus, definitely. But all of us are safe and healthy now, so let us be thankful for that. So moving on now, I would like to invite the ex-president of Genesys, Ria Titus Didi, a final year student of the biomedical department, to give the welcome speech for the conference. And the fantastic video which you just saw now has been made by Ria Didi only. Yeah, Ria Didi, please.
Thank you, Shaurad. Am I audible right now?
Yes, you're audible.
Okay, thank you. So good morning, everyone. I hope that everybody is staying safe and doing well. Genesys has done well since 2015 in conducting webinars and seminars in offline as well as in online means. And it was last year that we decided that we need to have something like a GenX conference where we'll be able to club everything together and provide to the participants. So from last year, we have been conducting this GenX conference, and this year we are conducting this GenXConference 2.0. And seeing the success from last year, we hope that this year also we'll be able to conduct a good one. So I am very honored to have this opportunity to welcome you all to this conference. And this conference is like the fruit of all the hard work that the Genesys team has put on for the past 6 months or so. So I would like to invite our head of the department, Dr. Kunal Pal sir, to this conference. Welcome, sir, to this conference. And I'd like to invite our other faculties have also joined us from the department. Mukesh Gupta sir is here. Welcome, sir, to the conference. And I'll also like to invite Khalid sir. Welcome, sir, to this conference. And I hope that all of you in like the experience and everything that is like shared in this conference will take you a lot, give you a lot of knowledge. And we have workshop on computer aided drug design by the Schrodinger company. I welcome the Schrodinger team also to this conference. Also, we have webinars on AI in biomedical image analysis, and that is being taken by Pratik Prasanna sir, and I welcome him also to this conference. And we have also a webinar on biomedical applications of CQD. So I also welcome the speaker Girish Chandra Mohanta sir to this conference. I also would like to invite the speaker of 3D printing, a novel approach in scaffold. So I invite Dr. Vignesh Vijayan to also to this conference. And we also have this competition on paper presentation. So I also welcome all the participants for the paper presentation also to this conference. And I hope that you all will get to enjoy and see this whole knowledge sharing is very precious. So what we can do by this knowledge sharing, it requires an appreciation, right? So we can contribute or appreciate this by participating in it. So I hope that all of you who are present in this meeting right now, I hope that all of you will stay till the end and gain something out of this conference. I once again welcome all of you to this conference and thank you. Over to Shaurad.
Thank you so much, Riyadi, for briefing our audience about the conference. We have with us Professor Kunal Palsar, who is the head of the Department of Biotechnology and Medical Engineering. Professor Kunal sir has always supported Genesys for doing events and webinars and spreading the importance of bioengineering among students. Now, I would like to invite sir for speaking few words on this occasion. Over to you, sir.
Thank you, Shaurat and Riya. A very good morning to one and all who are present over here. I thank you for joining us for the GenXConference 2.0, emphasizing new perspectives and advances. This conference, which will span for 3 days, January 21 to 23, 2022, is the second annual conference of Genesys, the bioengineering club of NITR Rourkela. The club, it is an active technical club of the Department of Biotechnology and Medical Engineering. As the head of the department, it is my pleasure to welcome all the esteemed guests to this 3 day conference who have come from various walks of life. The conference is being conducted in collaboration with the Schrödinger company. From the dignitaries from academia to the dignitaries from industries, my young colleagues have left no stone unturned to make this conference as interactive as possible. This conference has a unique theme which will allow the interaction between the academia and the industry personnel. Various interactive webinars from various guest speakers, workshops, and student competitions will be organized during these 3 days. Some of the notable dignitaries from academia include Professor Pratik Prasanna from Stony Brook University, Dr. Girish Chandra Mohanta from CSIR CSIU organization, and Dr. Vignesh Muthu Vijayan from IIT Chennai. The guests from industries who will be sharing their knowledge include Mr. Raghu R, Mr. Pritesh Bhatt, Mr. Vinod Devaraji, Mr. Kishore Venkatesh, Ms. Selvia Malik, and Mr. Kaushik Kasava Jhala. We would have liked to have you on our beautiful campus. However, the conference is being entirely conducted on the digital platform due to the COVID-19 pandemic. Okay, which is also the case across the globe. I hope in the future it would be a pleasure for us to welcome you physically at NIT Rourkela. I would like to thank and acknowledge all the delegates and the support team who have worked hard to bring the conference into today's reality. I request all the delegates and participants to take part in all the activities for the next 2 days, 3 days, in fact, sorry. I wish everyone a successful and fruitful conference. Thank you.
Thank you so much, Kunal sir. Along with academic excellence, National Institute of Technology, Rourkela, it promotes extracurricular activities to ensure all-round development of personality. The Student Activity Center, SAC, is the central hub for student activities, student organizations, programming, events, sports, recreation, and fun at the Institute campus. The Student Activity Center is organized into 4 primary societies and a host of satellite clubs. Besides, every society has satellite clubs that have their management under the overall supervision of SAC. Right now, we have Professor Poonam Singh Ma'am among us, the President of the Student Activity Center. Ma'am, I request you to share a few words with our audience. Over to you, ma'am.
Yeah, good morning to all the faculty members of Biomedical and Biotechnology Department, to all the students and all the participants of the conference. I am glad to know that Genesys Club, which is a club registered under SAC, under the Technical Society, is conducting this bioconference. The conference holds a variety of events like software workshops, webinars, along with the talks by great speakers from bioengineering field. And these webinars will be focused on recent advancements in the fields of carbon quantum dots, 3D bioprinting, and biomedical imaging. So this will help in linking the biology with technology and help in implementing the study of this field for the benefit of people. So I hope this will give knowledge about the recent advancements in the bioengineering field. And there are also workshops like computer-aided drug design, which will be conducted for the students nationwide. So computer-aided drug design approaches are widely used in pharmaceutical industry. So I hope this will also help in doing further research for all the participants. The webinars will also provide valuable insight into how carbon quantum dots could be used as a novel biosensing material and their applications in this field. 3D printing is already used to construct three-dimensional objects from CAD and digital 3D model. This webinar will highlight the recent advancements in 3D printing. So I hope this webinar will be helpful to gain knowledge, and it will help in further research in the field of biomedical. I wish success to all the organizers, and I hope all the participants will gain from this. Thank you.
Thank you so much, ma'am, for your kind words and appreciation. It really means a lot. Okay, so moving on, we have with us Mr. Raghu Rangaswamy, sir, the Vice President of India Operations, who joined Schrodinger in 2004 as a technical support scientist and has been promoted to his current position since 2013. Raghu sir manages the business development and administration of Schrodinger's India office. He will talk on current trends of CAD in industries. So Raghu sir, I request you to give over the talk. Over to you, sir.
Thank you. So good morning, everybody. Good morning to all the organizers and to the participants. And we are really happy to be part of this event. And I really appreciate the Genesys Club in organizing this GenX conference. In fact, like this is a really a good student initiative, which I have never come across because we do organize so many conferences and webinars, but students organizing an event like this and bringing various technology people to give talks, presentations, webinars is really a commendable one, because today what you need is the world is developing so fast, right? You know, like every 6 months a new mobile phone comes. The kind of development what you have seen today in the last 10 years, if you see the technological development in the era of digital and computational simulations or whatever, is transforming from a mechanical era to phenomenally, like today, like, okay, you just sit in at your home and take an app and book a cab or like book your grocery or name anything, like whatever you want. Like, okay, you look into an Amazon, like, okay, you just sit at your home, like, okay, open the website and order everything, right? It is all becoming more convenience, right? And in this way, like the GenX conference is also something really good, like, because in a way, like, okay, I'm sitting at Bangalore, not traveling from here to Rourkela, and you're all sitting at your home at your own convenient way, and not spending money on your travel, stay, or like wasting a lot of time and all those things. At your own convenience, you're listening to what is the technology, right? That is the way the world is changing. And thanks to the pandemic, even though the virus is evolving from Delta to Omicron or XYZ or whatever, human beings are much more capable in evolving and changing ourselves to the changing scenario of these things, right? So if you look at the emerging science in the drug discovery and the vaccine discovery, if you look at the last two pandemics, those people suffered a lot. In fact, my dad used to say, when he was young, like there was again a pandemic like this, and people used to go to villages and stay, like not travel and everything, and there was no vaccine. But today, like look into it, like India being such a populated country, like the vaccine like was able to come within a year, and we are being protected very well, etc. And the same way, if you look into the drug discovery scenario, which used to take 15 to 20 years to discover a drug molecule, and like where if you see in 1990s or 2000, the combinatorial synthesizers where randomly, like, okay, without knowing what is a target or whatever, you serendipitously synthesize millions of compounds and spend billions of dollars to discover, identify the one single molecule, and which takes like so many months to synthesize, test the molecules, etc. That scenario is changing today with the computational drug discovery. It was called earlier computer-aided drug discovery, but today we can confidently say it is computer-driven drug discovery. The reason why I'm telling you is if you just go and look into our website, Schrodinger.com, which is today owned by Bill Gates, Disha, Google Ventures, etc. All these technology giants are coming and investing in a computer, in a software company. And our founder, Disha, had a vision 35 years back that like, okay, in future, the drug discovery is going to be computer driven. Like I was reading an article like where 50 years back, somebody predicted the future telephone is going to be, somebody can hold on the hand like with no wires and it can translate, you can talk over that, so many things which came true. Like he was a visionary. So same way like Disha had a visionary, like told like the computer simulations is going to be a next wave. Today, I can confidently say we are screening billions of compounds. I'm not telling million. We screen 200 billion compound in just a week, which is equivalent to 2000 years of wet lab work. Look into the way like the time is reduced. And not only that, if when coming to the lead optimization, because the drug discovery is not like identifying a potential molecule. You might ask, when I go and meet many pharma R&D scientific chief scientific officers, they say like, yes, discovering a molecule, a potency is not an issue, but identifying like, okay, there are so many other parameters, the absorption, distribution, metabolism, excretion, toxicity, synthetic feasibility, bioavailability, so many other aspects. An ideal drug molecule has to satisfy everything. So when you are modifying any particular functional group, like the other parameter will go wrong, right? So this is like managing jack of all, like, okay, you have to make sure the molecule is perfect in every aspect. And today, like with the technological development, one on the synthetic, the way it changed from 2005, if I say the bioinformatics, the human genome sequencing, which came, through a lot of ideas on identifying the potential genes. And then the structural genomics came, like, which gave us the ideas of many structural, the structure of the proteins, because just with a single gene, you cannot identify what is the target. But when the structure came, the entire scenario of drug discovery changed from a serendipity to more of a rational drug discovery. So if I want to tell, like, okay, let us imagine you lost your key to the house. Okay, you go and ask a locksmith, okay, can you give me a duplicate key? Without knowing the lock, how can you give a key, right? So without knowing what is the target structure of the molecule or what is the target where it is binding, the era of drug discovery totally changed from a serendipity to a more of a rational approach. And now we are talking about the artificial intelligence, machine learning and everything, which is also helping to discover the structure of a protein, like, okay, near to what is the reality of these things. So these things have changed a lot. And when I was doing my bioinformatics, like, okay, we had an SGI computer, which was a lot less powerful than a mobile phone, what I'm holding today. So thanks to the computational power today, like, okay, we evolved from servers to clusters to cloud computing technology. So this helps today to simulate any molecule, even if you want to do a free energy perturbation to find out the binding affinity of a molecule, which took months. Today we simulate in 4 hours. So today, with the computer-driven drug discovery, we are able to tell to a chemist the molecule or the modification what you have done is going to give a better activity or a less activity within 0.5 to 0.6 kilocalorie per mole, which is really a boon to the pharma R&D. And the way today the drug discovery, my colleagues is going to give a presentation, you can see the way drug discovery scenario has changed. It is not like we screen billions of compounds and narrow down to just less than 5 or 10 compounds, completely using the computer-driven screening, and which takes in a reduced time frame. This is really a boon, and this is what the real pharma industry R&D is implementing today. Today, you won't believe, like, okay, I'm working in this company for 20 years. I never imagined in 20 years, like, okay, a pharma company will spend $15 million to buy a software for every year spending on a software on drug discovery. Or a company like BMS or like Sanofi or AstraZeneca comes and collaborates with a software company for $2 billion, $3 billion. Okay, we will collaboratively do a drug discovery. What I'm talking, you can all go and see in our website, in our news and events, like where the number of companies collaborating with us. So what I'm telling you is the change in the world is much faster than what you are studying in your academic degrees, right? And you have to catch up to this. Like if you want to get a job, like if everybody is looking for a job scenario tomorrow, you have to catch up to the latest technology, whatever is coming in. And the syllabus, what I see, the syllabus doesn't change to whatever the industry technology is changing. Every 6 months, you're not changing a syllabus. And even the changes in the syllabus is not accommodating to whatever it is coming. So where do you get this information? One way, like I really appreciate the Genesys team to identify these emerging technologies and educating these things. But yes, educating, attending in on a webinar is good. You get a knowledge, but that is again like only theoretically you're getting a knowledge. Where are you getting a hands-on? Are you using in your projects? Are you using your PhD thesis? And like, because an employer like me, like if I want to hire somebody, like, okay, it's not like your theoretical knowledge, it matters to me. It looks at like, okay, what is the hands-on experience you have? What is the knowledge you have gained? That is what is important. So I really appreciate like nearly like more than 100 people participating in this event. And my team is today doing for next 3 days doing a hands-on workshop. So you are sitting at your own convenient place. So don't hesitate to ask any questions to my team. And later on, even if you want to evaluate, want to use the software for any of your projects. In fact, like NITR Rourkela is our customer, like, okay, when there is a facility available, such these kind of technologies available in your place, please use it to the best. And whatever the project you can do, whatever the PhD thesis you can do, utilize it to the best, because you should be a different person from somebody like, okay, who is just learning something. Today, theoretical knowledge is not going to give you a job. It is the number of project what you did, like, or the publication what you did, what is the latest technology what you did, what is the latest technology you are aware of. So that is what going to give you a mileage comparing to somebody attending like who is just gaining a knowledge. So I appreciate the event organizers for organizing this event. I appreciate the participants for participating in this event. Utilize to the best. We are not charging anything to you. You're not paying anything. You are sitting at your own convenience. Learn it to the max. I appreciate all of you. Learn these things. My interest and my wish is India should change from a country of doing just service provider to an innovator. And if you want to innovate, all these new technologies, this next generation of the younger generation should learn all these things, be innovative. Don't be just a bookworm. Learn everything. Be a hands-on in whatever the technology you can learn. Apply it on your day-to-day, on your project work, research, PhD, or wherever you can. Innovate. Innovation is going to give you the credibility, the value, everything. All the best. Thank you. Jai Hind.
Thank you so much, Raghu sir. I think now at this pandemic, when all of us are home and we can't go to lab, I think learning the skills and developing those abilities, I think that is the new trend is in this COVID pandemic. So I really wish all the participants who have joined today, they will enjoy the workshop and all the other webinars and activities we'll be having throughout this journey. Thanks a lot, sir. So we also have Professor Mukesh Gupta sir with his teaching experience in biotechnology and medical engineering, animal science and biotechnology. His laboratory developments are in bioinformatics laboratory, computational biology, gene manipulation laboratory, software development and a lot more. Professor Mukesh Gupta sir is the principal investigator and coordinator of Center for Bioinformatics and Computational Biology of NIT Rourkela. Professor, I invite you to share your thoughts on this emerging fields. Over to you, sir.
Thank you. Thank you. First of all, thank you very much to the strong Scottinger as well as our Genesys Club to organize this. I'm very happy to see such a webinar being organized, and I really appreciate this Scottinger to coming forward to help our students to give hands-on the software tools that they have. It's not that easy for any company to do that for free of cost. Of course, some of them do. Thank you very much, Dr. Raghu, also for taking it. And he has very nicely said, he has elaborated so much about the computer-aided drug designing. to which the company is heading, and India is one of the leader, becoming a global leader. Of course, we are not at this moment, but we will. So, having said that, when Dr. Raghu was saying, I was just remembering my PhD days when we wanted to identify some drug molecules for reprogramming of somatic cells into the induced pluripotent stem cells. We are looking for that with the team from China and the US, of course, Dr. Shending. We were doing that. And, back on those days, we used to use what you call as a ultra high throughput screening. It's a big machine where thousands of molecules are to be synthesized and then screened on the cells, which our target cells. Lots of failures, very rarely out of one, probably out of 13,000, if I remember, is something which we used to be the target. And it's lots of cost consuming, time consuming, and frustrating many a times because we get nothing. And then came the era of the medicinal chemistry came to our assistance, and people get many information about the drug molecules, how they interact, what functional groups can actually give them better biokinetic, pharmacokinetic, or pharmacodynamic properties, and all develop quantity structural activity relationships. So every information of the structure of a drug or structure of a compound, organic compound in particular, and their influence on their binding to their targets, their influence to binding to penetrate the cells and to go and bind with the molecules inside. Many things came, and everything was quantified in terms of mathematical equations. And from where the computer-aided drug designing picked up. So as rightly said by Dr. Raghu, from the alchemy, from the serendipity, we moved into more quantitative valuations. And then today what we do is that most of the things that we used to do, 20 years back, we used to do experimentally and waiting for luck to favor. Today we don't do that. Today we have number of software programs which can do plenty of computational analysis of the structural activity, the functional groups present within them, and how they may bind with your target molecules and do. So back on from those days, today we are in a world where we can predict how a molecule can bind. So you can have thousands of, if you have a drug target, okay, suppose this is the drug receptor, for example, if you can stimulate, if you use an antagonist or agonist to stimulate that, you will have some effect. If you know a drug target, we can screen millions of drug molecules in the market, and we can predict whether they will bind with them or they will not bind. So starting from hit identification to lead molecules, and then even the lead optimization, that how we can optimize what functional groups that can be changed to have better activity. Everything can be predicted. So instead of thousands of molecules that we will experimentally validate and waste time, today with the help of computer-aided drug designing, we can narrow it down to few hundreds or few thousands, and then we have a greater chances of success. So this is something, a technology which has developed a lot, and today every drug industry use this. And as you rightly pointed out, it is so rapidly expanding in academia, like in our organization. It's very difficult to catch up with one coursework or one laboratory work. It is impossible to catch up. We just are able to instill the very fundamental, very basic. But the companies, the industry is growing, exponentially, progressing, and it's rapidly going. Technologies are being changing. Skill sets are limited, and many of the softwares are highly expensive, beyond affordable. To many of the universities, organizations, it's highly expensive. Of course, for the students, some companies like Schrodinger or the V-Life and all comes with a subsidized rate or sometimes free. So it's a good opportunity for all of you to take this advantage, go through their softwares, learn how to do it, and how this software actually work, how this software or what mathematical equations they follow, how to optimize the lead compound and so on. I'll suggest everybody to take full advantage of this. And thank you to the Schrodinger to organize this for our students. And I really appreciate Genesys coming forward with such a good idea. So with all that, all the best to all of you. Please take full advantage of it. Good luck.
Thank you, Mukesh. I really appreciate, looks like you have a good experience in the industry aspects also. So it's not only the computer-aided drug discovery, there is also another aspect, the materials discovery. Okay, that is really changing, because today, if you take Boeing, they look at which material can reduce the weight of the flight, or Samsung looks at the light emitting diodes, which material can do it. There also the computational driven things are reduced. See, you end of the day, it's all the properties, right? What is a property of a molecule should have, and how can you screen it fast, using the quantum chemistry or these things. In fact, if you are interested, okay, we are also establishing, I don't know how much the drug discovery is done in your institute. We are selecting about 10 institutes in India and establishing a center of excellence in the drug discovery and materials molecular simulations. So that is to give a hand-holding experience. Not only that, because the industry academia collaborations and tie-ups are very limited in this country, which I really feel somewhere we should bridge the gap, because you go on your own silos, and the way industry goes is much faster. So that gap up has to be merged. And the way today, India is not only the pharmacy of the world in synthesizing and producing the medicines, it is also becoming the R&D hub. Because if you look into the newspapers, you take any CRO today, name any pharma company, big pharma companies, they're all sending their molecules to India to synthesize, test everything. That's a manpower and do the drug discovery here. Due to the pandemic things, they are not able to go and work there. And here in CROs, you look into I can say in the last 6 months, Jubilant, SciLife, GVK, Syngene, everybody expanded more than 1,000 hoods of chemists, more than 1,000. And the attrition rate is so high because the required manpower, you take computational chemistry, more than 25% is the attrition rate. The required manpower is not there. So this has to catch up. So we are there to work, if there is an interest, because the interest should come from both the parties. We are there to lend you the hand, if you want to come up, because I want this country to be an innovator country. That's what is my wish. Thank you.
Thank you. Thank you. We used to do with earlier, I had a tie-up with the V-Life. And then, of course, during this pandemic, our work activity has slowed down. In our institute, as a whole, we have 3 major areas, as you rightly pointed out. The material science, another area, material informatics. And we have a very dedicated faculties who are working in this field. Faculty from the Department of Metallurgy and Material Sciences, they work on it. Even some faculty colleagues from the Department of Chemistry. We have joined together and we have established now the Center for Bioinformatics and Computational Biology. It is funded by the DBT, Department of Biotechnology, Government of India. It's a DBT center we have established. And these are the 3 areas we work. One, as I mentioned, the material science, of course, the drug designing is one part of it. Both the molecular dynamics and simulation studies also we do. We have HPCs with us in our institute. We have 5 HPCs, and a good number of servers have been funded now with the Government of India. The only problem we face is we use, as you very rightly said, we use most of the time dependent on our own softwares, in-house written programming languages, or we use the open source programs. Funding agencies, we are non-profit organization. The funding agencies, they do give money to buy the softwares, but then no company gives us a perpetual license. So they give it for short time, and it's very difficult, and they are becoming so expensive. So that becomes there. I really appreciate your offer to jointly work with us. If it is there, we'll be very, very happy to. Schrodinger is there. One of my RA is he's a very fan of all the programs. He's not there today here because of some family issues, Dr. Praveen, and his whole PhD work was using your software only. So I'm very happy with your offer, and we will be happy to have further discussions on it. So whenever you have time, so let's take it forward, and let's see how we can work together and for mutual benefit and for the country as a whole. Our students, I tell you that our students are extraordinarily good in mathematical skills, computational skills. So you tell them to write a program, they write. Only thing we have to tell them is the algorithm and the logics, and then they write it. So, and there is something, your company will be far benefited from our students. They may not be able to tell you many of the drug designing parameters that you might look. But if you want to develop your program, I'll tell you, our students are wonderful. So many of our students could be, you will judge even when you are giving, your team is giving, you will realize that our students are fantastic. So they do work, many of them work on computational work. In this pandemic, many of them most of them have taken the in silico drug designing as their project. Of course, they do not use the Schrodinger. I'm sure half of them, or maybe more than that, will take your program now. So it's win-win situation for us, for you, for as well as. So let us take it forward. I really appreciate your support, and let us take it forward.
So by the way, like we are expanding in a big way in India. So we are going to hire about more than 200 scientists in the next 1 year. So that's the way the expansion is going on. And for your information, Schrodinger is not just a software provider. We also have our own internal drug discovery, and also we do collaborative drug discovery. We do more than 30 drug discovery collaborations. So that's where like, okay, and when you are telling, and we give you at 95% discounted rate what we sell to commercial. Okay, so but when you say perpetual, you say like any technology, you say like, okay, let us take in 90s, it was QSAR, then came docking, then QM. Today we talk like artificial intelligence and like free energy perturbation. Technology is changing. And like if you're not changing as per the technology, having a perpetual software is of no use. And companies also like they all vanished. So world is looking short.
But I tell I will request you to please, when you are taking the training programs, you also have a, in between, you can judge our students. You can try to gauge the capability.
No doubt about Indian students. No doubt about any Indian student. And particularly who are all in IITs and IITs.
Our students. I'm talking of my students in particular. You will find, you can gauge them. You'll find it very much useful for employment in your country, your company also. Please have a look at that. And we can talk on this further for how we can jointly work together for the center.
Yeah. Thank you.
Thank you. Thank you.
Thank you so much, Professor Mukesh and Raghu sir. Slowly we are moving toward the ending of this opening ceremony. So now I'll introduce all the speakers from Schrodinger. Dr. Prajwal Nandhikar, he is a recipient of the prestigious DAT Fellowship to perform research at Heidelberg University. Prior to joining Schrodinger as a senior scientist, he has 4 years of postdoctoral research experiences in various types of molecular modeling techniques to understand biological processes. His research interests are computer-aided drug design, quantum chemistry, and multi-scale molecular dynamic solutions. Next, Dr. Pritesh Bhatt. He is currently working as a principal scientist at Schrodinger, Bangalore. His doctoral research involved the identification of inhibitors for various enzyme targets of Mycobacterium using different computational modeling approaches at Birla Institute of Technology and Science, Pilani. Post PhD, he joined as research scientist at Informatics and Modeling Group, Novel Drug Discovery and Development of Lupin Limited, where he successfully collaborated with the medicinal chemist, the biologist in design and delivery of NCEs in target to hit to lead and optimize lead for a wide range of therapeutic targets. Next, Mr. Vinod Devaraji. He is a senior scientist at Schrodinger, working with computer-aided drug discovery research for 9 years. Initially from 2011, he had taken care of the technical support on Schrodinger software as an application scientist, which gave him the opportunity to interact, train, and support many academic and commercial customers in various Asia-specific countries. In this tenure, he has research experience in topics such as computer-aided drug discovery, DNA intercalations, organometallic compounds, and biologics. Next, Dr. Kaushik Kasavajala. He is currently working as a senior scientist at Schrödinger GmbH at Bangalore. He holds 8 publications to date with more than 2 in preparation. His work has been cited at more than 3,500 times. He has presented in numerous conferences and workshops. His research interests include developing enhanced sampling method and force fields for biomolecular simulations and designing antibodies and drug molecules. Ms. Shelvia Malik. Ms. Shelvia Malik has pursued her undergraduate in biochemistry and molecular biology with a minor in chemistry from Pennsylvania State University, State College, PA, USA. She joined Schrödinger Incorporation's New York, USA, and worked with the development team for the force field project, where she developed algorithms for the integration of force field functions in the molecular dynamic engine using C and C++. In January 2019, she took up the role of account manager and business development office for Schrödinger India. Mr. Kishore, the associate solutions architect, provides technical support to users. Well, this was all about the speakers from Schrödinger. Now we have reached to the ending of this opening ceremony, but this is just the start of the conference. I really wish and hope we all learn and enjoy a ton of things from this conference and make good memories, obviously, which are virtual, and take them back with us. And with this, now I officially announce the GenXConference 2.0 as open. Thank you all for joining us. It was really great having you all with such a huge number of participants. And this was all from my side, and that's it for the opening ceremony. We really welcome you to our conference, and we hope you will participate in all the webinars and presentation and in this workshop, obviously. So yes, the conference is officially open now. And now I hand over the meeting to Dr. Prajwal Nandhikar for starting the cloud-based hands-on workshop. Over to you, sir.
Yep.